I wish to illustrate what is oil trajectory analysis. I promise I will use the acronym OTA just here. There will be a brief explanation of what is oil trajectory analysis, the provided information, results in Mediterranean Sea, and how can be used. So oil trajectory analysis, it's a data set of oil spill trajectories lasting 10 days in coastal areas, produced for 5 years. For 5 years because the purpose of this data set is to provide significant statistics on the oil transport. Trajectories are simulated backward in time. It's a little bit unusual, so there will be a couple of slides that will illustrate this technique. So on what is backward in time integration or reverse modeling? Now on the left is shown how an oil spill, a conventional oil spill works, oil spill model works. So we have an oil spill offshore, and then the oil is moved forward in time up to the destination. Instead, on the right side, you can see the concept of backward in time integration. We start from a receptor point that is the red dot on the coast, and we go backward in time. We track the oil trajectories to possible sources. So you see below the two, it's the same equation, but it's integrated forward in time on the left and backward on the right. Now, this concept of backward in time integration, it's an old concept. This was probably for the first time was implemented in a pioneer oil spill model that was used by NOAA. It was the Sardus Material Group in Seattle of NOAA, which developed this concept. And this group is famous because they worked on the famous Exxon Valdez oil spill in Alaska. Why this concept of reverse modeling or backward in time has not been used for 40 years? It's because this concept is very requiring in terms of the data needed. The needed data are sea currents and winds. But while the winds data were more or less available in the past years provided by meteorological organization, the problem was with the sea currents. So this is the reason why this concept of reverse modeling can be applied today, because we have a huge data set of sea currents as a sample provided by the Copernicus Marine Service. So in this application of the Mediterranean Sea, I've been used sea surface current from this two data set. And the technique of reverse modeling has been applied for each one of these red dots on the coast of the Mediterranean Sea. And this is an example of application. In the figure A, you can see 5 oil trajectory starting on 20 of July from a receptor point on the Algerian coast. And these are tracked backward in time from 20 July to 10 of July. All these 5 trajectories start at the same time, probably it's midnight, are tracked backward. And in the figure B, you see all the trajectories tracked for 5 months of July from 2015 to 2019. The trajectory have been released every 30 minutes from, in this case, from point A. And in figure C, you can see the trajectories starting from point A and point B. And the common area is plotted in dark red. But the sense of the common area is that an oil spill occurring there probably will reach the coast in points A and B. So now this work has been done for all the black dots on the coast in figure A. So it was a huge number of simulated trajectories, because trajectories start every 30 minutes from each one of the about 3,000 points all along the Mediterranean coast. So the important thing of the oil trajectory analysis is that this database establishes a link between the coastal sites and the sea cells. This trajectory have been reported over a regular grid of the sea, sites at about 4 kilometers. So the information provided is that in any point of the sea, as point G in figure A, we have the total number of trajectory crossing the sea cell. Where do they come from? From the points on the coast. How many trajectory come from each point on the coast and the relative arrival times. So in figure B, you can see the influence area of oil spill that will beach in point S5. So we have a sort of climatological picture of the oil transport for each one of the points of the coast. This is another example of the information which is provided. This is for a group of points, as could be a marine protected area. So again, in figure D, we have the influence area from where the oil spill are expected. Please note that these figures are done, or the data set is organized on monthly basis. So we have these maps for each month. And we have, so the influence area in figure D, average travel time, minimum travel time. So this picture are refer to receptor points on the northern coast of Crete. In summer, as shown later, most of the oil transport comes from north, from meteoceanographic resource. So now, in this picture, are reported the main oil tanker routes, they crossing the Mediterranean Sea, and the marine protected area, which are colored with different colors in different areas. I will briefly show you these 5 examples that probably are the most critical cases from A1 to A5. This is the Spanish coast, and you can see the difference between summer in August and in December. The probability that is shown in figure B and C is the pitching probability for an oil spill. And so in light green is shown the probability higher than 5%. And you can see the difference. This is the area Spanish coast from Cartagena to Alicante is probably critical because we have the oil tanker routes, and in this area, the oil, from the climatological point of view, in this case, probably are winds that will push the oil quickly towards the coast. That in winter, in figure C, the situation is different. Probably the most critical area are west of the Ibiza and Palma. These are the maps of the North Mediterranean. North Mediterranean is particularly critical because in figure A, you can see in blue is plotted the Pelagos Sanctuary, which is a protected area for marine mammals, and you can see how many cold tanker routes cross this area. And probably the most critical situation is in January, northeast of Corsica, and in summer, in figure C, it's along the Italian coast here, Genoa and Spezia. At the bottom is shown the Sicily Channel, and it's interesting to note in summer, in July, the island of Malta or Pantelleria, there is a huge probability that the oil spill can reach the northwestern part of this island. This is mainly due to the strong stable currents in the Sicily Channel. It's are well studied current system like the Atlantic Ionian Stream, uh, which sort of that reach the northwest of this island is high. This is another example. In the Aegean Sea, as example, in summer, you can see the effect of the Meltemi wind. It's a Meltemi wind. It's a northern wind, almost constant in summer in this area, and so the oil should reach the northern coast of the island here. And you can see in figure A how many oil trucks, oil routes cross the Aegean Sea, which are directed to the Black Sea at north or to southeast to the Suez Channel. Around Cyprus or on the eastern tip of the Mediterranean Sea, also in summer, the oil transport is very energetic. Okay, so now these are the last slides, and how this information provided by oil trajectory analysis can be used. Now, this picture, I put this slide because this is a SAR Sentinel-1 SAR, synthetic aperture radar image, showing an oil spill occurred north of Corsica. Probably you can also see the ship causing this oil spill. That is the white dot here on the eastern south border of the oil spill. So, I wish to say that SAR satellite images are a very efficient tool to detect oil spill. However, the oil and also the SAR images are provided by are currently provided by many operational satellite constellations. It's Copernicus, Sentinel-1, Terra-Sarixi, Cosmos Skynet. These are European. COMS-5 is Korean. RadarSat is Canadian. So we have a lot of SAR satellite constellation. But if we detect a noise spill like this, oil trajectory analysis is not the best tool to predict the beach insights. I can explain this better. If we have an oil spot like this, we have that we have the beaching side provided by oil trajectory analysis, but it's much better to run a conventional oil spill model because this is driven by wind and current data of the following days, which provides much more reliable forecast than the beaching sites provided by statistical analysis of the. So, which is the purpose of oil trajectory analysis? It should be the next slide. Okay. Oh, sorry. Okay. So oil trajectory analysis should be used for planning satellite surveillance. Now, uh, satellite surveillance is done by the CleanSeaNet service of the European Maritime Safety Agency, but the monitor areas are where oil spill most frequently occur at its past, and the sea area requested from each single state. Should be also included the sea areas where oil spill quickly and massively can reach. So this is now this information is available and could be used for this purpose. Also, this image shows how many satellite images can be available. These are only the satellite images available from the Cosmos Skymet satellites, but we also have Sentinel-1 and Terra-X. So we have a lot of satellite images. So the problem, and also this number will be growing because we have many private operators that are introducing into the satellite market, which also provide provide images acquired by small satellite SAR sensors. So we have the necessity to introduce priority criteria in satellite surveillance. Now in this picture, I try to select some most probably the most useful images. So this is an organization that suggest or a possibility the results of oil trajectory analysis. So this is okay. Thank you for your attention, and I am happy to give answers.
Thanks a lot, Achille, for your nice presentation. And yeah, it was really interesting, and we have a few questions for you, so we will go to that now, and I will read them. The first question being, in addition to tracking the oil trajectory, are the positions of the oil drills, the height of the drilling machines, and impact of sea currents also monitored?
I have to understand what position the oil drills, the height of the drilling machine impact us. Yeah, but the answer could be yes, because the starting point of the oil trajectory analysis is sort of climatology on transport. So it does not matter much how the oil spill can be generated by obviously the impact of the sea currents is the crucial point of this analysis. The climatology of the oil transport is built basing on winds and sea currents. So this last point of the question is the answer is yes.
Okay, thanks. Okay. Next question, is the algorithm able to track any kind of oil spill? I mean, irrespective of the type of spillage? I don't know how to pronounce this word, sorry.
I don't know what is tire of spillage.
I think maybe it's a typo mistake, like type.
The type of oil.
Yeah, I understand like that, yeah. I'm not sure.
Okay, so I missed during the presentation, I missed to talk about the weathering effects in oil spill modeling. because it depends on the type of oil. So, as a sample, heavy fuel, since heavy fuel for many, just a little bit part of the heavy fuels disappear or evaporates. And as a sample, diesel, most of diesel vanishes. But when we purpose of this work is to understand if the oil can hit some coastal sites. So if the oil, most of the oil evaporates, good. It means that the oil spill occurred that will not hit, or in a small part will hit the coastal site. But it's a sort of we don't know exactly in the future which oil spill will hit a specific coastal site. So I would answer to this question saying that uh, it's it's a preventive action. So we can expect worst as usual.
Okay, okay, thanks. Thanks for trying. Okay, a more open question about the use of your model. Can the oil trajectory analysis model be used to search for aircraft debris in the event of a plane crash at sea?
Well, we this application for oil spill, we have a motion equation of the oil. So the concept is probably the same, but the application need specific
Yeah.
evaluation of the. Yeah.
Okay, thanks. Okay, next question. How long after an oil spill happened can it be detected in openly available ocean data apart from SAR data? Which parameters does it influence?
AR, radar data are the best tool. Obviously, satellites provide monitoring of large area. So this is the reason. Also, SAR data satellites are not affected by clouds, are not obscured by clouds. So this is another reason. There are other oil spill can be detected also by other satellite data, but I I can say that the main tool is our satellite, and SAR data are surely the best. Now, without entering in details on satellite detection of a spill, which parameters does it influence? Oh, obviously, danger, danger. Uh,
Okay, thanks a lot. Okay, another question about the presentation. In the figures, there were oil-shaped tracks. Could you explain what they are? Is it an AIS with filters, or does it include all ships in that area?
uh, Basically, in the AIS data, there are some fields that tells you which kind of ship is. There are some classes of, ships, and so can be selected by the AIS data. Anyway, the tracks, the oil tanker tracks in the Mediterranean can be found in many papers, published papers, or almost known because we know the ports or the passages through the straits. So it's a consolidated information.
Okay, okay, thanks a lot. Another question about the model. Do you also account for the stock's drift and tidal currents?
These effects should be included um, in the sea currents data that are used in the simulation. So the marine service, Copernicus Marine Service data accessed are produced by models. So this is surely they include the Stokes drift and tidal currents.
Thanks a lot. Okay, one question. How does this tracking, differ from the oil spilling advisories used in operational services like that by the Indian National Center for Ocean Information Services?
I don't know. I never tested this system. I don't know if they have modules to uh, perform a reverse modeling application. So I don't know. I collaborated with Indian scientists in the past for the tar pollution on the west coast of India, but it was something like 8 years ago. So I suppose that 8 years ago.
Okay, thanks. Okay, so we have time for two more questions. Okay, so do you use a specific model to consider specific oil characteristic, or is it a language drift model that is used? We can't hear you very well.
Oh, sorry.
Okay.
Okay,
Oh.
oh, sorry.
No, it's okay,
No?
we can hear you now.
Okay. The oil characteristics are not considered in reverse modeling because it's preventive work done before the noise spill occurs. So we do not know which will be the next oil spill. Will it be a strong, fastly evaporating oil? We don't know. So it's for this reason it's not considered. In this type of oil is not considered. Also because if most of the oil evaporates anyway, cracks or little fraction of the oil anyway will reach the coast. The answer is, from technical point of view, it's Lagrangian risk
Okay.
model that is used.
Okay, thanks a lot. And we have time for one more question. So the last one being, the tracking of the oil is more 2D-like due to buoyancy, so winds and surface are dominant. What will depth, 3D, and modeling add to the models?
Yeah. I, uh, uh, in my opinion, the best use of this oil trajectory analysis is for to understand from where oil spill are dangerous. Uh, So this is the classic question at the beginning of this study. So the tracking is bidimensional. It's surface tracking, and the purpose is to understand which sea areas must be monitored first for a specific coastal site or a marine protected area. So this is the purpose, the basic question and the application of this study.
Okay. Okay, well, thanks a lot for your answer, Achille. And yeah, thanks again for your participation. It was really nice to have you, and thanks again.